Furthermore, if you look at something like, let's just take ketones for instance. Ketones are a category of aromatic compounds. The majority of them are associated with aromatics such as butter, brown sugar, some of these really rich, deep characteristics. However, others of these are related to fruit-like tones. So I could even think that I'm right about some kind of compound that I am creating in the coffee through a certain roasting process, and I could be totally wrong about what that compound is. Adding complication to that, when you have simple sugar, which is a subset after these things have broken down, these will become simple sugars such as glucose. Fructose glucose and fructose are subsets of sucrose. So even if you have sucrose in your original green coffee, through these processes, they will break that sucrose down into its more simple sugar, and then that simple sugar will break down very, very quickly. It's a very fragile molecule. Fructose molecule is very, very fragile. So a lot of seasoned roasters will also say that a lot of the sweetness that we get out of coffee is perceived sweetness, that the actual sugar content in brewed coffee is very, very minimal. So those ideas behind I want to stay longer in caramelization in order to make my coffee sweeter, or I want to stay longer in the Maillard reaction in order to make my coffee sweeter, that is actually a myth. You're not going to make coffee sweeter by breaking down a sugar molecule.
Joel, I think that bears repeating.
Okay, so if you are thinking that by stalling out in a Maillard reaction or by stalling out in caramelization that you enrich the sweetness of your coffee, which I would say correlates to body as well, that you will not have that reaction. That is not going to be the result of what you're trying to go for. Because if you have a sugar molecule and you break that sugar molecule, it's no longer a sugar molecule. If you have a complex sugar molecule, like for instance sucrose is a fairly complex sugar molecule, and you break that down into its smaller sugar molecules, such as fructose, that fructose molecule will break very quickly. And when you are using heat, which is energy, but heat energy for these processes, this is a domino effect. So it's not like as soon as that sucrose molecule breaks down to fructose, that you can then drop it out of the drum and capture that. These things are happening well before first crack. Well before first crack. As you are seeing browning in your coffee, and as you begin smelling aromatics that are not the aromatics of green coffee, you know that these reactions are taking place. And by nature of that, you're creating a chain reaction, a domino effect, that will do away with any sugar that is actually in the coffee and simplify that. Now, there are caveats to this. If you start with a coffee that has a very high sugar content, then you'll probably end up with the residual sugar left in that coffee being at a higher level. Okay? If you have a coffee that is very dense and holds a lot of material within it, then that by nature says that you have more residual sugar at the end of your roast. Plus, it's holding on to a little bit more of that. There are some theories that if you take a longer amount of time, which is what I preach with a more dense coffee, in this area, that you may actually be able to cause some hydrolysis to use some of the actual cellulose, which is the structural material of the seed, and go through this process while you are in this early stage and provide and maybe build into the seed more sugar than it had before you had it in the drum. Now that is theory. I don't know. You can do flavor analysis on your coffee and do some experimentation. I would say that it would probably work for some and it may completely destroy others. So it's not a hard and fast rule. Okay. Do you have that rope you can pull me out of the weeds on?
No, you're doing fine.
Okay, good.
You're using Maillard and caramelization the same.
So let's talk about these. Let's break these up for a second. Talk about the difference and talk about the similarities. I'm using them the same because within our roasting process, they are more than likely and generally are happening at the same time. Okay? So if I have a cell structure, there's our little nucleus. This cell may have a whole bunch of sugar or potential sugar in it. Okay? This part of this cell, if it's isolated, if that sugar is isolated and the heat starts breaking it down, these molecules are going to start breaking and they're going to have simple caramelization. Simple caramelization is going to happen. Simple caramelization is the dehydration of sugars through the heating effect. So as you have your simple sugar and it breaks, it gives off that molecule of carbon dioxide, it gives off that molecule of H2O, and you have now something, it actually will give off chlorophyll, which is a direct correlation to caramelization. And chlorophyll is actually a bitter compound. And it's an aromatic compound. So whenever you say, I smell sweetness, you're probably smelling something like this. It's not actual sugar that you smell. So this process is very simple. However, if there are amino acids present, proteins, and there generally are within coffee, there's a lot more going on in that cell than just sugars hanging out, then you have the Maillard reaction. And the Maillard reaction is, I put plural here on purpose, it is a set, it's an umbrella that covers hundreds and hundreds of different kinds of reactions. Because, for instance, if you have one type of sugar with one type of amino acid, that those two will come together, and depending on the arrangement that they come together at, you could have several different reactions, and the result of that could be several different compounds. Now, extrapolate that to coffee. With coffee, we are starting out with about 300 or more volatile or potentially volatile compounds within the green coffee itself. So the way that those react, that's an exponential equation. The way that those react is basically incalculable to our ability to sense exactly which reaction is happening in which cell at which time. We can't do it. So that is why I kind of cram these together, because there is so much going on. There's no way to know whether this is happening or this is happening. And on our probe, of course, we could say the Maillard reaction happens at this temperature to this temperature. But our probe is not giving us exactly what that temperature is at this cellular level at any given moment.
With this particular coffee.
With this particular coffee, right. Or this particular drum material, or this particular amount of flame or heat exchange that's coming from the air.
Joe, for those that aren't on drum roasters, a lot of home roasters view this in. This is going to be roughly at about 5 minutes of a particular roast.
Yeah.
On a smaller electrical unit, you may be up at the 6 to 7 minute roast. But this is when all the green hues of that coffee are gone. Okay. Roughly 320 to 340 degrees.
It very much depends. Some probes I've seen will read this happening at 275. A lot of your larger roasters will have it at a smaller or at a lower temperature because there's more bean mass around the probe. The probe is further away from the drum wall. So it really varies. But no matter what this temperature is, that doesn't matter. What matters is on your drum, where does it happen? And how long has it taken to get there, or on your air roaster or whatever you have. And then how long is it going to take you to get from first crack, or from this, to and through first crack. So now let's talk about first crack. What is first crack? First crack is not a magical point at which the coffee now begins to go through a certain type of change. First crack is a reaction to all of these things happening. So as caramelization happens, you have your simple H2O and your simple carbon dioxide breaking off from that sugar. That's why a lot of people say that first crack is a release of steam pressure, But it's not just steam. All of these other things are volatile compounds that will break off of a molecule. Some of them will be stored in the seed and some of them will not. When you grind your coffee, that beautiful aromatic expression that you get from coffee is these that are captured in the air because they're gas. They're now in the air and you're smelling them. Okay? So, as Maillard reaction and caramelization happen, new molecules are created that are inflating that seed. You will have first crack. That's why it's really foolish of us to look at everything after first crack as being development. Because then if we rush up to first crack and then slow it down, we may have just missed all of this time where all of these things could be developed in the coffee. Okay? So that is why it's really important for us to pay attention to all stages in the roast. Look at these marks as milestones, as transitionary points where you can measure time. But that is another reason why I use 30-second increments to measure my time, is because I know that that will give me a closer snapshot as to how my curve is developing. Now, I just got done saying, don't sit there and study your curve, study your curve, study your curve. Sure, draw your curve. Cup your coffee. Then go back to your curve. Cup 20 different roasts, 20 different curves. Cup them all. See which one has the expression of that coffee that you like the best. And then work your way backward through that curve, starting with that time from first crack on that has traditionally been development. I want to kill that word. I just want to call this post first. Okay?
Can I get an amen?
And I want to call this pre first. Okay? And then first crack happens. Between yellow and first crack, we are browning, but browning happens all the way through. Okay? It continues to happen until you're into blackening. Okay? So browning would be at yellow. That is an actual physical change where you're converting from one type of energy change to another. You're converting from endothermic to exothermic. Okay?
Explain the difference.
So that endothermic, once again, you are absorbing heat, absorbing energy. Exothermic, there is now chemical change, and at every point where you have a breach of a compound, every point where you take a sugar and you break it, there's a tiny bit of energy that is actually released. So at that, when you go into exothermic heating, you are actually creating energy. You're using energy to cause the reaction, and then you're using energy to make sure that that chain reaction continues to happen, but that is actually creating energy at the same time.
Is that why you pick up your airflow at first crack?
Correct. Yeah, I pick up my airflow well before first crack, because again, first crack is a reaction. First crack is not the action, it's a reaction. So if I have, here's another very key point I want you to think about. If I have some of this moisture left over, hanging out, when I should be going through these, if in this cell there's a bunch of water just kind of hanging out, that water is quenching these reactions. I cannot have Maillard reaction if I add water. I cannot have caramelization if I add water. And if you're holding on to a lot of water in your drum or in your seeds,